So I'm going to now describe the use of PassBits. So PassBits are similar to in their goal to ordered hashing. The goal here is to reduce the length of unsuccessful searches, and that means that we want to, when we do a search, we want to decide that the element is not in the table before we actually reach an empty slot. So we want to save these extra checks. So what we do is we associate with each bucket an extra bit. This bit is false if no successful search continues through this bucket, and is true otherwise. I like to think about it in slightly different terms. The bit is true if a previous insertion created a collision at this bucket. So that would mean that later, if we search for that item that we inserted, it will have a successful search going through this bucket. Okay, and the complement is that there is no insertion created a collision at this bucket. Okay, so because initially everything is going to start up false, I'm going to use this plus in order to indicate true, and false I'll just use an empty, just no indication. Okay, and remember, initially all table entries have their pass bit equal to false, and so that is because initially we haven't made any insertions yet at all, so so of course there is no collision. Okay, so let's look at an example. Here we have a table with 1, 2, 3, 4, 5, 6 locations, and we inserted into it cow, dog, pig, ape, and cat, and they all fell into an empty slot, so there were no collisions in those insertions. And now we want to see if we have rat in the table. Okay, so now we're looking for a rat, and what do? We compare it to cow, and we see that that it's not equal to cow, and then we also see that there is no, the pass bit is false. So that means that we're done, and because we didn't find it in this place, rat cannot be in the table. Okay, so suppose now that we want to insert the rat that doesn't exist in the table yet. We're going to do that first in the most standard way, standard double hashing. So so basically we look at this rat here. It has a collision here, 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 and finally we can put it in here. Okay, so so that's where we put it, but now we need to update our pass bits, so that would be done like this. So basically these are all of the locations that we went through on our way to getting to the location where rat is. Okay, so next time that we are searching for rat, we have to basically go through all of these locations, so we have to mark them all as plus. Okay, so we can basically do a very similar thing using Brent method. Okay, so if we use Brent method, Brent method, then when we put rat, it collides here, it collides here, it collides here, and it collides here, but here it turns out to be more efficient in terms of successful searches now to put rat in here and to put ape here, because that's one less move that we are adding. So that's good. But now, what would be the pass bits? So the pass bits would be similar to before, but no pass bit on the cat because we didn't go through the cat, through this node. Okay, so finally, when we've have this table full where we inserted rat using the Brent method, let's see how do the searches work with the pass bits. Okay, so here is first we're going to search for an ape, and ape is green, so that means that the start location is here, and ape, we don't find it here, but we do have a plus, which means we have to follow the green arrow to the next place, and here indeed we do find ape. Okay, so we found ape, and the plus was important for that. Okay, and then let's see about searching for DAO, something that doesn't exist in the table. So in this case, we're going to compare DAO to cow, not here, so we have to go to the next one because of the plus. It's not equal to dog, go to the next one, not equal to pig, go to the next one, not equal to rat, go to the next one, and it's not equal to cat. And there's no plus here, so we don't need to go to the next step, and at this point, we know that there is no DAO in this table. Okay, so that's basically how the pass bits are used. Any location where the pass bit is false is a location that acts exactly like an empty place where we stop if we don't find the thing that we were looking for.